We've scanned the device. We've checked out its ports. Now it's time to get more information. Let's enumerate. With enumeration, we're going to do sort of a systematic approach to get info out of the target device. We're going to use information that we got from our recon, our footprinting, to know which devices are worth enumerating. We'll exploit normal functionality. You see, the thing with enumeration is you're going to use normal protocols, normal functions, and the device, the target, will just think it's a normal client coming to talk to it. And that's how we do it. What do we get out of it? Well, operating system service details, users in groups, email addresses, contact info. Yes, we get some of this through OSINT and other things, but enumeration is where we get it from the device itself. We'll get network information, network shares, network resources, route entries in a routing table, audit and service settings. We'll also get SNMP and DNS information and machine names. We can get banners from applications as they greet us. So how do you approach enumeration? You use normal tools. You act like a normal client making a legitimate information request. Now, some of these normal tools are tailored specifically for enumeration, but they behave to the device, to the target, like they're normal. So when you enumerate, just focus on what you need. Don't get so much stuff that you get all cluttered and there's a bunch of stuff you don't care about. You'll do a combination of manual and automated enumeration for the best results. Here's a banner grabbing example. I use Netcat against some server port 80. I get back a normal HTTP 200 OK response, meaning the server just thinks it's just a normal client. And the server, as part of its banner, as part of its hello, says, I'm a Microsoft IIS 6. That's the part I care about. Now I'm going to go look up exploits for Microsoft IIS version 6. Here are some more enumeration examples. Using Nmap with the cap O, which means try to figure out the operating system for me. Or the scap-v, interrogate the service version. Or here's a script, an Nmap script, SMB tech OS tech discovery. Try to do SMB enumeration. Here's using RPC client. If you have a username, you say techu and then the username. You see, with Active Directory, which is what RPC client is so good at, you can really get stuff from Active Directory. Active Directory has this thing where any Joe Blow user who's a member of the forest has the right to read almost anything from the Active Directory database. In fact, there's a server called the Global Catalog server that is used for those kinds of lookups, well, at least to tell you where things are located. So if you know the user, and they don't have to be an admin, they could just be whoever, you put in the username. You can do it without the username, but you'll get far better results if you have some kind of username. Then you can say, okay, give me server information, look up names for the administrator, look up security IDs. If you don't have a username, just say techcapu, quote, quote, I don't have a username. Here's an example using Metasploit. So we will use auxiliary scanner SMB. This is the path to this particular module, the SMB lookup SID module. And we'll put in a username and a password. Maybe we chatted some guy up. Maybe we social engineered them. It's just a normal standard user, but we managed to get their password out of them. And now, since we're looking up SIDs, I want you to start from 1,000 to 1,100, which means the first 100 users that were created in Active Directory. And then we're going against this particular domain controller and run, hit it. There are many tools to enumerate services and information. You have Nmap scripts and Metasploit modules for just about everything. Plus there are other tools as well. For FTP, TCP/21, and folks, please memorize these ports. You will need to know. Of course, you can use any Telnet or FTP client, as well as these Nmap scripts and Metasploit modules. Same thing for SSH. We have Nmap scripts, we have the Telnet and SSH clients like PuTTY. We have Metasploit modules. For Telnet itself, same thing. For SMTP, for email services, for the outgoing services as well as email relays. Again, we have PuTTY and Telnet clients. We have Nmap scripts and Metasploit modules. For DNS, the usual lookups plus dig and NSLOOKUP, and just a command prompt. For HTTP, a ton of tools. Again, the usual ones, but some kind of Telnet client like PuTTY, Dirbuster, and we actually talk about a number of website enumeration techniques elsewhere. For remote procedure call, RPC, we can use RPC Info, RPC Grind, MSRPC Enum, plus a whole bunch of other tools. For NetBIOS and SMB, we have the usual suspects, as well as lots of tools meant specifically for SMB and NetBIOS, NBT Scan, Enum-EXE, Enum for Linux, SMB Client. For SNMP, there are so many SNMP clients. There are command line clients. There's SolarWinds, GetIf, PRTG, What's Up, Nagios, Spiceworks, Observium. I've used, I think, all of these. We have all kinds of tools to query Active Directory and other LDAP-type servers. So for LDAP, you can use Active Directory users and computers, NTDS-Util, which is the Microsoft-supplied command line tool for Active Directory. Other LDAP clients like OpenLDAP and LDAP Admin and LDP, which Microsoft teaches people to use, as well as the scripts and the modules. If you're going to query remote procedure call over 445, which is the port for logging into Microsoft machines locally, well, not locally, but local Microsoft machines over the network, you can use RPC Client. You can use all the Metasploit and Nmap tools. You can also use a bunch of small command line tools, which are really powerful. User to SID, SID to user, PowerShell. There are whole PowerShell things. There's a whole collection called PowerSploit. You can use the PS tools. We're going to play with a number of these things. For SQL Server, which listens on TCP 1433, you can, of course, use the usual scripts and modules, but there are a ton of SQL tools. And if you want, you could use Enterprise Manager for SQL Server, get a free copy for SQL Express. You can also use the alternate port for LDAP for the Global Catalog Server. You'll recall that I mentioned that the Global Catalog Server will tell you where objects are in the Active Directory forest. Now, it is true that Active Directory domain controllers will tend to use the secure LDAP port, 636, but they will respond to the insecure LDAP port of 389. So this is our look at enumeration. And now, on to the next topic. Let's dig a little bit deeper into SMB and NetBIOS. We'll start with NetBIOS. There's been a fair amount of confusion as to what's the difference between the two. So let's clarify that. Let's clear it up. NetBIOS stands for Network Basic Input-Output System. Yeah, okay, big deal. It is a layer 5 session layer protocol. It's also an API. It's what Microsoft adopted in the early days of its small LANs. It's broadcast-based. It allows computers to find each other and communicate using NetBIOS names, the old Microsoft-style names. Now, these names had limitations. For one thing, you could only use letters and numbers, and I think you had to start with a letter. And you certainly couldn't start with a special character. The characters could be 1 to 15 in the name. There was a hidden 16th character in the name that would describe the name type, because the NetBIOS name, the computer would have several of these to indicate the different services that it offered. The only special characters you could have would be a dash, a dot, an underscore, or a $sign. And that was okay until Microsoft started adopting TCP/IP. The $sign has the special meaning. It means the name or the share exists, but it's hidden on the network. Of all of these, only the dash is truly compatible with DNS naming conventions. So, for example, a dot in DNS means hierarchies, so you sure don't want a computer name that implies a hierarchy on the same name. Like, is the computer this or this level? I don't know. The underscore is reserved for SRV service records. You can't use it just in a normal name, and dollar is illegal, so only the dash is compatible with DNS for host names. Microsoft, like I said, used NetBIOS for simple LAN communications, for name resolution and file sharing, and originally it was used by that broadcast-based network protocol called NetBEUI. When Microsoft adopted TCP/IP later, they then kind of bolted NetBIOS on top of TCP/IP, and we called it NetBT, NetBIOS over TCP. NetBIOS uses several TCP and UDP ports. You can see it's TCP 137, 139, UDP 137, 138. And again, it discovers other hosts by broadcast, so that's why the several ports, for broadcasting, for responses, for opening up sessions. Here are the NetBIOS names. You don't need to memorize this, but just so you're not surprised when you see these. You'd have the name or the domain name, and it would be followed by whatever that 16th character is, implies a code here. And it would be unique to the host, or it would be for the whole domain. And it would then mean something. So like if I had the name computer1 and then followed by 00, that's the host name. Or if I had a domain like example, back then it wasn't .com, it was just example, right? There's no hierarchy in original Microsoft domains. That would be the domain name, and this 000 means, okay, domain name. And you'd see all these names associated. And then you'd have 03, that's the messenger service, and that implies the user that's logged on at that moment. Then 20 implies that, hey, I am a file and print server. And 1D means I'm a master browser for that particular subnet. Back in the old days of NT, the master browser would collect a list of all the available machines on the network and then share that list with other computers. Or, if I am in a domain, then 1B is I'm the PDC emulator. I'm basically the boss of the domain. Take an old Microsoft class and you can learn more about this. So don't be surprised when you see these additional codes for NetBIOS names when you use NetBIOS tools. They just indicate something about that particular host, the services that it runs or the position it has. Now let's talk about Server Message Block, SMB. This is the current Microsoft file and print sharing protocol. Microsoft machines will have a workstation service called a client, and you can go into services in the control panel and see this. The client, the workstation service, will connect to the server service, the server. And by default, all Microsoft machines have both the client and server service running when they boot up. It means that any machine can be a file and print server or a client to somebody else. You can be both at the same time. Server Message Block, SMB, is the one that we use. Machines also kind of talk to each other using a hidden share called the IPC share, inter-process communication. It allows one process to communicate with another process from two different machines across the network, and actually allows them to do something simultaneously. This IPC share is hidden, and so you can look in shares. You won't just see it browsing on the network, but you can connect to it by manually putting in the name. It's IPC $, meaning it's a hidden share. Now, how do NetBIOS and SMB work together? Originally, NetBIOS was the way you got on the network. Microsoft wanted to improve that, so they created SMB, and initially, SMB used the NetBIOS API, so it was SMB over NBT over TCP. So that was the way it worked back in the NT40 days. Now, by the time they got to Windows 2000, they said, we'll just take out the middleman NetBIOS, it's kind of silly, and SMB can directly be a payload of TCP. So the SMB client would use the NetBIOS API to send a command to an SMB server, and it would listen likewise for responses. And the server would use the API, the NetBIOS API, to listen for incoming requests and send the responses. Like I said, since Windows 2000, which is over 20 years ago, there are still Windows 2000 devices out there, believe it or not. SMB now runs directly on TCP 445. Why am I telling you all this historical stuff? Because you can still use NetBIOS-based tools to enumerate. It's so cool. NetBIOS still exists for backward compatibility. In the Linux-Unix world, they decided to reverse engineer SMB version 1, the file server service, and call it Samba. How cute, Samba, SMB. So when you see the Samba service on a Linux or a Unix machine, it's acting like a Microsoft file and print server using SMB version 1. And NetBIOS and SMB have a long history of vulnerabilities, which means vulnerabilities that would affect a Microsoft file and print server will also affect a Linux or Unix machine running the Samba service. So that's pretty darn cool. How about enumerating using NetBIOS and SMB? We can use SMB to make NetBIOS calls to the Microsoft server service, and we can get all sorts of stuff. Computer names, shares, users, logon info, password policy, dump password hashes, the NetBIOS computer names, domain names, Active Directory names, fully qualified domain names, system time, and that's just the beginning. There's more. Now, NetBIOS, and remember that IPC dollar share that I was telling you about? That had a particular vulnerability. Okay, so remember how I mentioned something called the master browser, or the browse master, actually, is what it was called. Well, you'd have one machine, and in a domain it was the PDC emulator, or the PDC rather, not the emulator, the PDC, the primary domain controller. Back in those days it was the writable copy. You'd have one machine, and if you didn't have a domain, they would elect one, but you'd have one machine that would collect all of the names of the computers on the network and store it in a list. And it would share the list with every other computer. That's how you could open up, well, back then we called it Network Neighborhood. Now it's Network, it went through several names. Network Neighborhood, My Network Places, I think it's just Network now. But anyway, that's how you could open it up and see a list of all these machines. Well, how did it share this? It shared it via the IPC dollar share. But here was the funky part. When one machine wanted to get the list from the browse master, it would log in into that share with no username and no password. Which meant that hackers, figuring this out, could use a tool pretending to be another computer, requesting information, NetBIOS information, using no username and no password. You could make a connection. So when you would first try to connect to a machine and enumerate NetBIOS info, you'd get access denied. Make a null user connection, and suddenly, boom, sure, here you go. This, while this doesn't exist as so much of a problem now, you can still, even today, you can still change settings to allow for this for backward compatibility. A null user is basically a user that has no name and no password. We used it in the old days for Windows devices to log into each other and trade the network browse lists. And for decades, this was an exploit that took advantage of this. So you would just say netuse, which is a way of mapping a drive, and then //, or in Microsoft parlance, whack, /, not /, either the name or the address of the machine you were trying to connect to, /IPC dollar, right here. And that IPC dollar meant I am trying to connect to your hidden share. with no password and no username. You map a drive to IPC dollar, and then you can query for all kinds of information from that device. There's another tool that's been around forever, Microsoft gives it away for free, called NBTStat, NetBIOS over TCP Statistics. You can display NetBIOS over TCP protocol stats, name tables, and the NetBIOS name cache. It's one of the very few command line tools in Microsoft that's actually case sensitive. Now here's one of my favorites, the net commands. Net has 19 subcommands to get information via NetBIOS. You can also use it to create things. I like to use the net user command. So you would just say net, and then space, then user, and then you could create a username with a password and just create them. And then you could net local group and add that user to the administrator's group. So we can use the net commands to get all sorts of information. Enum for Linux is another tool. It's a query tool that will run on Linux. I can't imagine with that name. It will enumerate NetBIOS information from Windows or Linux Samba. And you would say enum for Linux, and then what do you want? Tech all, get user list, get machine list, etc., get share list, get password policy, and the like. Or get group and member list. Here's an example here. So I want to enumerate stuff, and I'm just getting information about shares. You can also use a GUI tool called ShareEnum, which does the same thing. And what's cool about this is this will enumerate hidden shares as well as regular shares. So that's cool too. And by the way, just so you know, Microsoft machines, all of them by default, share their C drive. In fact, share every mass volume as the drive name or the drive letter followed by a $sign. It's a hidden share. Now, by default, only admins can connect, but hey, we find ways to get around that, right? So ShareEnum, really good GUI tool for this. SuperScan, which is really just a scanner and a pinger and a hostname resolver, but it too will give you Windows enumeration information, and it'll banner grab and do other stuff. There are some other NetBIOS enumeration tools. The NetBIOS Enumerator, NS Auditor, with all sorts of tools. Hyena, which we play with, it will enumerate SMB and NetBIOS and SNMP and LDAP and DNS and a whole bunch of stuff. And WinFingerprint, which will give you the operating system, users and groups and SIDs and the like. And these are just some of them. So that's our look at doing NetBIOS and SMB enumeration. And now, on to the next topic. In this activity, we're going to use a tool called Hyena to enumerate information via the NetBIOS protocol from a Windows machine. This will work against pretty much any Windows machine, but we'll use Server 2016. So right now, you see the local workstation. You can expand, and there's information already about Server 2016, including its drives and all the folders. Pretty cool, huh? Including any local connections, any users, any groups, loads and loads of built-in local groups, any printers, any shares, any sessions, which we have none, no open files. How about the services? If we double-click services, probably see a whole list here in just a moment. Yep, here are all the services and their status. I kind of like how you've got green or red, assuming that you're not colorblind or have some sort of visual disability. We can see the drivers. I double click it and I'll see all the drivers. Here are all the drivers. I can see any event manager events. So here are just events from like system, and these are the event log events. Here's disk space. I can see user rights. So there's a lot of stuff here. Loads and loads of user rights, like a network logon user right. If I double click one of these, I can see who has the right to log on, everybody in Server 2016 Network Interactive. So lots of user rights. If we go back, let me just collapse some of these things because it's getting so long. I can see performance information. I can see any scheduled jobs. I can view the registry. Man, this goes on and on. This is awesome. I can do WMI queries. And that is it for just the local machine. Lots of enumerated stuff. And that is how we enumerate information about a machine via NetBIOS using a tool like Hyena. Let's talk about using the file transfer protocols for enumeration. And let's start with the oldest one of all, well, just about the oldest one, FTP. FTP has been around forever. It's clear text. Just about any operating system can use it, and it has something unusual. It uses 2 channels, 2 ports, not just one. One of the ports is for commands. The client sends commands to the server, and there's communication back and forth. The other one is for data. When the client asks for something, the server provides it on the other channel. Now, you might think, okay, that's fine, but it can get us in trouble, especially with firewalls, so I want to address that. By default, the command port of FTP on the server side is TCP/21. And for the data, it's TCP/20. Now, sometimes it can be random. We'll get to that in just a moment. You can configure an FTP server to either authenticate a user, username and password, or to just allow anonymous connections. And if you log on to an FTP server anonymously, you use the word, the name anonymous as the username, and then you put in anything you like for the password, because the password isn't checked. So that's what anonymous means. We can use the FTP protocol to enumerate information out of a host. This is a model of the old style of FTP, the original traditional style. We called it FTP active mode. As with all clients, the client will use 2 random ports, way up there, the dynamic ports, assigned by its operating system. It will talk to the server's port 21 for commands, and it will talk to the server's port 20 for data. But notice how the arrows go. This is the interesting part. The network definition of a client is the side that initiates a connection. That is the network definition of a client. And the server listens on an open port or has some service, and the service can accept or reject the connection attempt. In TCP/IP with TCP and UDP ports, that acceptance or rejection, unless there's some kind of policy or something, is usually based on whether or not there's a service listening on the port. Okay, fine. In the original traditional FTP active mode, the client would only initiate the connection for the commands. The server would then in turn initiate the connection back to the client for the data. Now, that might seem okay, except one thing. These days, both servers and clients have firewalls protecting them. Whether they're hiding behind an edge device on the network or it's a software firewall on the machine itself, they generally both have firewalls. Now, what is one of the things that a firewall in a default configuration will do every time? If there is a connection attempt coming in, and that firewall is not configured to acknowledge that, it will reject it. It'll drop it. And you probably won't hear anything. So here's where the problem lies. The client will create a connection. It'll create a connection going out to the server, no problem. You configure the server's firewall to allow that. But as part of that connection for commands, the client will tell the server, hey, I'm going to listen on port so-and-so. It's then up to the server to make a connection back to that port on the client. The problem is that the client's software does not tell the firewall about that port. So when the server, coming from its own port 20, tries to hand data to the client to initiate a connection for data, it's the client's firewall that says, what? This port isn't open, and rejects the connection attempt. It blocks it. So they can be talking with commands back and forth, but when there's an attempt to create a connection to send data, the client never hears it because its own firewall stops it. That was the problem with FTP active mode. So what do? Well, the solution was to come up with something called passive mode. Now with passive mode, the client will initiate both the command and the data session. When it initiates the command session, the server says, hey, let's start with this port. Let's do data. Come talk to me on this port for data, not 20. That's fine, because the client will understand that. The client will then initiate a data connection to whatever that port is, outbound. We know that firewalls, by default, after you've configured them to allow any traffic, by default, firewalls will allow connections outbound. And once you've made the outbound connection, any return reply is okay, is accepted. Because the firewall, even a stateful firewall, especially a stateful firewall, will say, oh yeah, you started the connection, sure, I'll allow any responses back. So this is FTP passive mode solution. It's up to the client to initiate all connections, command and data, no problem. So now, how do we use FTP for enumeration? Well, we do have FTP commands such as get, meaning download, put, meaning upload, but there are others that will allow you to emit information from an FTP server, accounts, passwords, whether or not we allow anonymous logons. You can even bounce commands off of an FTP server to, say, port scan internal targets. So what are some of the tools we can use? We could netcat. We could use netcat or telnet to banner grab from an FTP server, find out what kind of FTP server it is, what version. So like, here's an example. I'm going to netcat, and I don't want you to try to resolve the name. Give me verbose output to this IP address 21. And I get a banner back that says, oh yeah, welcome. I am VS FTPD version 3.0.3. And then we do a Google search for exploits against that particular FTP server. See if there are any. Okay, that's one thing we can do. Nmap also has loads of scripts to see if FTP allows anonymous connections, to try to brute force passwords, to try to bounce commands through an FTP server to something on the inside. We could also use a tool called FTP user enum. So this is used to enumerate operating system level user accounts via the FTP service. And it works against a particular type of FTP server, the one that runs on Solaris, the in.ftpd, as well as the GNU iNet Utils, FTPD. Now we have FTP's little brother, TFTP, Trivial File Transfer Protocol. No authentication. Clear text, yes, UDP 69, non-interactive. You can't browse anything. You have to know the name of the file that you want to upload or download. But you might be able to guess. We typically use TFTP servers these days for uploading and downloading either operating system files or configuration files for network devices, routers and firewalls and switches. And those config files are all clear text. If you know the name, or if you can guess the name, you could, without being challenged to log on, download a configuration file. You could do it by its default name. So like, for example, Config files for Cisco devices are just called startup-config. So you could say TFTP and then that TFTP server. You know it's a TFTP server because you did a port scan. It shows up in UDP 69. Then get, and then the file that you want. So how do you use TFTP to enumerate? Well, you could guess the names of the files. No one's going to authenticate you, and they're not going to set NTFS permissions. They can't because there's no way to prove who you are. You could use an Nmap script that'll just use a list of possible file names, which you can specify or not. So like, for example, we'll say, Nmap, we're going to do a UDP scan to port 69. We're going to use a script called TFTP TAC-enum. Then the NSE means Nmap Scripting Engine. Oh, and by the way, the script is going to be, the file list will be this right here against this target. Now, keep in mind that when you make an unauthorized connection to a TFTP server, it's still unauthorized. Even if they don't enforce any kind of authentication, you're still not supposed to be there. It's just that they don't enforce it. Then we have Network File System, NFS. This is the file sharing for Linux and Unix type machines, the NIX machines. The client will take an empty folder, an empty directory, and it'll connect to a share, and it will mount that share. So you create some little directory, you make a connection, you make a connection to this share over here from this NFS server. The connection stays persistent, and when the user goes into this little folder, they're actually seeing the content from the share. That's the network file system. There are tools to enumerate that because, of course, any shared files are probably going to be interesting. So you can use RPC info. You'll have to install RPC bind. So we could say on a Linux machine, sudo apt install RPC bind. Then we have this tool. You can use RPC scan, get it off of GitHub. You could use SuperEnum, also available on GitHub. You could use the NFS client itself to enumerate shares on the network. So you can see in this conceptual diagram here, I have a client machine and I have a server machine. They connect to each other via the networking layer. Now the server has disks and it has directories which it shares. The client has its own file system, the root and all these different files and folders, and the user will create an empty directory which will communicate across the network layer to the share on disk. The user uses some application, goes in here. From the user's perspective, it looks like a local directory, but it's really getting stuff across the network. So here's an example of using NFS. On the file server, we would add a line in a file, etc exports, to allow anyone in the subnet to read or write to the share. So it's like, in this line, or in this file right here, we would add a line. In the home directory, a subdirectory called whatever you want to call it. And frankly, it doesn't have to be home. It's just, this is an example, makes it easy for a user. We'll call this folder SRV share, whatever. And we'll say that the entire subnet here can read and write and sync. Okay. Then we have to run a command to export all the shares in the etc exports file, because once you set it up, you got to actually say, okay, implement. So we'll just say export fs tac-a, all. Then we'll start the NFS server process. And we'll just go to a path here to this script, NFS tac kernel tac server, and start it, run the script. Okay, so now we're sharing. On the client, what we're going to do is we're going to create some kind of folder, some kind of directory. So we'll make dir in our own home directory, call it whatever we want. And then we will mount, and we do it in admin privilege and root privilege. We'll mount of the type NFS to the server's IP address or resolvable name, their share, the pathway to their share, and then the pathway to our folder. And that is how you do NFS. So these are the different ways that we can use the file sharing protocols, the file transfer protocols, to enumerate information as we dig a little deeper into our target. And now, on to the next topic. Let's talk about the single most powerful tool we have to enumerate information from a Microsoft Windows system, and that is WMI, Windows Management Instrumentation. This is Microsoft's implementation of a common standard called Web-Based Enterprise Management, or WBEM. This is a standard way, a standard technology of accessing management information for all sorts of things in your enterprise. It is based on something called the Common Information Model, the CIM or KIM. This is a standard for representing systems, apps, networks, devices, whatever you care to manage. We can connect to the local machine to get information, but we can also use DCOM TCP/135 to make remote connections to query those machines for their WMI information. WMI is organized in something called a namespace. It's a hierarchical structure, kind of like a folder structure. The namespace that we use, for the most part, is something called root CIMv2. It's like the top of this tree structure here. Within that CIMv2, that KIMv2, there are 277 classes that cover computer hardware, software, and configuration. So you can see under the namespace root, we're just listing two classes right here. And these are sort of like the templates. These aren't real network adapters. They're the class of type of device. Underneath that, you can see we have the real devices. So under this class of Win32_network adapter, there's NIC number 1 and NIC number 2, or whatever you happen to have. And then let's say we have this other class that we're listing here, the Win32_disk drive, and under that we have one physical disk. Like I said, there are 277 WMI classes in KIMv2. These are the most commonly queried ones, and you'll notice they all start with Win32_. Then after that, it could be the BIOS, boot config, computer something, time, disk partition groups, route table, etc. Over here, operating system, process, processor, registry, servers, share, system users, etc. So you have a lot here. Now, whether or not you have instances under these, I don't know, probably. You can use PowerShell to query WMI. There are a lot of built-in commandlets. The most common PowerShell command that exists now is get-kim class. It'll give us all WMI classes. This is actually a relatively new command. It replaces the obsolete get-WMI object. Now, you can right now use either, but the get-WMI object is considered deprecated. Realize that PowerShell is not case sensitive as you query. So here's an example here. Let's say I want all the information about a particular class, like get-kim instance -class name, and then whatever it is, Win32_processor. It'll give me information about that class in general. Or let's say I want to have all classes that happen to have processor in the name. I can use wildcards. Within single quotes and then wildcards, you put that string that you want, and then it'll return everything that has that string in it. If you want to format your output, you can get-kim instance class, whatever the class is, pipe ft. Now that's just a PowerShell thing. It's an alias for format-table, which means it will return the output table format. So you can see we're getting Win32_process and then formatting that. So you have all the little processes and then all the little columns with all of their attributes. If you want to auto-size your table, you can pipeft-auto-size. One of the problems of PowerShell, and this is a PowerShell thing, is that sometimes tables are, when they come out, the columns are truncated a bit, so you see part of a name and then dot dot, and you don't know what the rest of the name is. So if you FT, format table, and then dash auto-size, it will expand or shrink the columns, resize the columns as needed. So it's very, very convenient that way. We could also see all of our results in a list format. So instead of seeing a nice table with all of the instances and all of their little column attributes, instead it's like a list. One instance with all of its attributes, the second instance with all of its attributes, etc. So you can do it either way. You can view it either way you wish. You can also use a query language called WQL to query WMI. This is a subset of ANSI SQL, so it is based on the SQL language. It has the same basic syntax as SQL. Select something, some property, some column, right, from some class. Treat it like a table. Examples: select star, meaning select everything from win32_BIOS. Or select name, which is one of the columns, one of the properties, one of the attributes of win32_BIOS. Or select two attributes, select name, version from win32_BIOS. So if you wonder what are all of the properties of a particular class, come back to this PowerShell commandlet. Get-kim instance-class name, whatever you want, and you run that, and it'll show you all of the properties. And you can go, name, version, this, that. Oh, I want these two, or I want these three. And then you include them in this WQL query. Now, you can use WQL in PowerShell, other kinds of scripts, custom apps, anywhere you would use a regular SQL query. When would you do WQL and when would you do PowerShell? Because they both are ways to query WMI. Well, WQL sometimes gives you better performance than the equivalent PowerShell commandlets. However, that said, it can also be more complex to create a query that gives you the same thing as an equivalent commandlet which has been written with this specific thing in mind. There are a number of tools that you can use to enumerate or even exploit WMI. I've listed some of the most popular enumeration tools. SolarWinds has a free WMI monitor. Codeplex has WMI Explorer. There's also Hyena and PowerShell. If you want exploits, you can go on GitHub, and here are just a few of them. Metasploit also has modules. So there are a number of tools you can use to both enumerate and exploit. And here is an example of the WMI Explorer GUI. So now we've seen Windows Management Instrumentation, which is the most powerful query platform that we have to find out information about a Windows machine, its hardware, or its software. And with that, let's move on. Let's do some enumeration using WMI. You can get so much more information than you can from, say, NetBIOS. And with pretty much any Windows machine, WMI is already running. So we can just enumerate just about any Windows machine now. We're going to use Server 2016, Windows 2000, and Windows XP for this. And the reason why I have both of these clients up here is because we have to do something to allow WMI queries for XP and later. 2000 does not have a problem. In Server 2016, come over, and click Start, and find Hyena. Expand Hyena, and launch Hyena. Hyena is a really powerful and very popular tool. I know of government agencies that use it to manage their networks. When this registration comes up, just click OK. The default is to open up the local machine, and then also, if it's part of an Active Directory domain, you'll see stuff under Enterprise. Well, we're not part of an Active Directory domain, and we don't really need to be. If you are a part of an Active Directory domain, you can automatically go into all of the other computers in it, but we don't have that. So the first thing is to just look at local information. It's really amazing how much you can get. Expand the local machine. You can see drives, you can see connections, you can see all the users, the groups. I mean, look at this, just amazing. Let me scroll down some more. Printers, shares, you can see any sessions you might have, none. Any open files, none. Services, let's see if we can do that. Okay, we can see all the services, see whether they're started or stopped. Look at drivers, my goodness. Events in the event log. I mean, there's a ton of stuff here that we can look at. Disk space, user rights, so the privileges and the rights that users have. We can take a look at performance. So how about process? What's going on? These are all the processes running. How about the processor? Double click that. These are the 2 cores for the processor. Do we have any scheduled tasks? Yeah, we do. Can we look at the registry? I mean, my goodness, we can just go on, and we can even see WMI specific information. So there's all this stuff we can get. This is really awesome stuff. But we're just looking at ourselves. We want to add other computers. To do that, click File, Manage Object View. Click that. And what you can do is add the other computers here. Now, it's not an Active Directory domain, so in this drop-down, hit the drop-down, and the first thing we'll add is the Windows 2000 server. So it's a server. And its name is W2K. Hyena is going to need the UNC path, the Universal Naming Convention path, in other words, the network name, as part of the configuration here. So in computer path, type \\, because that means UNC, and then the computer name, W2K. And just click OK. Now, Windows 2000 allows you to just make connections. If you're having some kind of trouble expanding W2K and it says access denied like that, just right-click W2K, just right-click it, and log on as, click that, and then just put in the domain or server name. You want to put in the name of the target, W2K, the username is administrator, and the password is lowercase password. Okay, and then just click OK. That's if you're getting any access denied. In Windows 2K, just give it a moment to make a connection and all of that. Now we can just expand what's in Win2K. So we can see the users. Heck, we could expand this, see the groups that a user belongs to, and get information about them, their password. We could again see local groups. We could expand one of the local groups and see who the users are inside, the group members. Again, we can see printers, share sessions, all of that. Now, what if you're trying to add something that is not in a domain, but is XP or later? You have to do something to permit remote WMI connections. Now, if we were in a domain, this would be no problem, but we're not. We're in workgroups, and we have no security relationship between the machines. Even though we know the username and password to use, we still have to set a registry setting. I have the instructions handy right here. In XP, click Start, Run, and type regedit, just like that, regedit. Click OK. We need to go into HKey local machine. HKey stands for handle key. HKey local machine system current control set control. Okay, so HKey local machine, select that. Expand system. current control set and expand control. You're looking for the LSA, the Local Security Authority, the LSA right here. Click that. There are settings. You're looking for a setting called Force Guest. You need to double click it to open it, and you need to set its value to 0. So let's come over here. There's Force Guest. Double click it. If it's not already set to 0, you need to set it to 0. So 0. Click OK. And you can close the registry editor. You'll now need to restart XP. So let's just restart XP real quick. While that's restarting, we're going to come over to Hyena. Scroll up here, close up W2K. We're going to add XP Pro. Click File, Manage Object View. The type is a workstation. The name is XP-Pro, and the computer path is XP-Pro. Click OK. We'll probably need to add a username and password. Right-click XP Pro, log on as. We're going to log on to XP-Pro as admin. Because when we look over at XP Pro, we can see it's admin, and the admin password is password lowercase, Password. Click OK. Give that a moment, and as soon as it logs on successfully, we'll be able to expand XP Pro. So let's expand it. We can see the users, the groups, etc., shares, printers, all the stuff that we saw for the other computers. The sessions, the open files, the events. I really like this fact that we can go and look at events. We can look at security events. Were there any security events? No. Any system events? Yep. We can look at user rights, and we can just say, okay, who has the right to log on across the network? Just click that. Oh, all of these people do. So very, very cool. You can go on and on. What about performance? How much memory does XP Pro have? Double click it. Looks like it's got about 78 megs of memory that has been committed for use, about 4 gigs available. You can even see page faults going on. Wow. How about system? 17 processes. Can I double click that? Well, maybe not here. Maybe I need to go to process. Click process here. Yeah, I can see the processes. I could see scheduled tasks. I could add a scheduled task, couldn't I? Yeah. Well, this would really help a hacker. Could view the registry. I can look at the WMI information. So like WMI itself shows us information like event logs and computer system, that kind of thing. This is really cool. I can understand now why security officers in these government agencies would use this just to see, okay, how are these things configured? What's going on with them? Go into the application events, see if there's anything in applications. How much disk space is in? Who is a member of the administrators group? Wow, some pretty cool stuff. So that's our look at using WMI to enumerate information from various Windows machines. And now let's move on. Now let's talk about enumerating using SNMP, the Simple Network Management Protocol, and you can get lots of information from SNMP. Well, depends upon the device type. So SNMP has been around for forever. It's used to centrally monitor all the devices on a network. You'll have this typically third-party software, the SNMP manager, and it'll go around and poll agents, which are little bits of software running on the various devices, and it'll poll them for information. And it just goes around, round robin style, on regular interval every couple of minutes, saying, hey, switch. And it'll ask various questions that are relevant to a switch. The manager knows what types of questions to ask because it has something called a management information base, the MIB, the MIB, the men in black. No, just kidding. It refers to the MIB to know what types of questions are appropriate for that particular device. And the MIB is just a list of questions. The questions are not formulated in English. Instead, they're just like a string of hierarchical numbers, but each one of them is unique in the whole world, and if you send that string of numbers, then the agent will go, oh, you're asking that question, let me give you the value. Such as, have you had any security violations? What is the version of your operating system? What is the temperature of your CPU? Do you have any failed fans in your chassis? Are any of your interfaces overloaded? So it just kind of depends upon the questions. And it's up to the administrator to decide which MIBs they want for the manager to ask the various devices. And when you install a third-party product, they have just like a recommended set that you can just use out of the box. So that is basically how it goes. So what's the security for SNMP? Well, first of all, in the early days, the first 3 versions of SNMP, it was all clear text. If we could sniff it, we could find out all sorts of things we're not supposed to know. Version 1, 2, and 2C were all clear text. Now, there is a version 3 that is encrypted, but not all devices support it. In fact, Microsoft does not support version 3. What else can you do to protect SNMP? Well, there's a concept of a community string. It's a very, very simple authentication mechanism. You can liken it to like a workgroup name in a way. It's just a text string, like a name or something. And when the manager comes to ask questions, it will identify itself by the community string. And if the agent is not configured for the same community string, it just won't say a thing. There are 2 default community strings. There's public for read-only, and there's private for read-write. Here's the kicker. Many administrators don't change those default community strings. So if I just install a rogue SNMP server, which I downloaded for free, and I just say, okay, public, first of all, go discover everything, and then go query every device for all the information possible, ain't nothing going to stop me. So that's the downside of SNMP. SNMP uses 2 UDP ports, 161 for querying and for the agent replies, and then 162 for what are called traps. A trap is just an alert. Usually the agent just sits there and waits for the manager to come around and ask it questions. But in case something pre-configured happens, like my disk hit 90% utilization or my CPU is at, some temperature or something like that, it can send an alert, what we call raise a trap. That's done on UDP 162. So here's an example. I've got this SNMP manager. You probably install this on a workstation, not a server, and it's just going to go around the network and say, hey, you, how full is your disk? And hey, you, what's your port utilization? And hey, you, what's your CPU temperature? And hey, you, got any security violations? And then maybe this guy has been configured to send an alert. So it sends a trap saying, hey, I have a problem, blah, 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 whatever the problem is. The components of SNMP are you'll have the device, what we call the managed device. Router, switch, hub, firewall, computer, service on a server, like DHCP, DNS, whatever, printer, IoT device, something like that. It's going to have that little agent, which is simple software installed on it, which will respond to the network management system, the NMS. The network management system is software installed on some kind of dedicated monitoring computer. So here's an example of an object identifier. It represents a question that an SNMP manager can ask. So we don't, like I said, ask in English, hey you, did you have any security violations? Instead, we'll say like .1, .3, .6, .1, .2, blah, blah. And each one of these represents a hierarchy. This guarantees that all MIB questions, regardless of the vendor, the product, whatever, they're all unique. So you have this object ID, this OID, that represents a single question that an SNMP manager can ask an agent. It will identify something very specific, a unique counter on a device. It will have a corresponding name and data type, so the corresponding name is this, the data type is, it's an octet string or whatever it is. When queried by the manager, the agent will return a value. So a management information base, or MIB, is a collection of these OIDs, and it's in a text file. And when you install an SNMP manager, it will load all kinds of MIBs so that it has all sorts of things to use. The MIB, of course, like I said, is a set of questions that an SNMP manager can ask a particular device regarding its status. And every device will have its own MIB, or it will use like a common MIB. So like you can pretty much ask any switch questions that are relevant to any switch by using a MIB that's common to all switches. You don't have to load something very specific from a vendor. Now, a vendor might have an additional MIB that is specific for its product that you'll load on top of like the common switch MIB. But in most cases, you can get away without loading anything specific from the vendor. So we have these standardized vendor-neutral MIBs that define functionality common to all devices of the same type. And then you want to get additional MIBs from the manufacturer, fine. An agent might use multiple MIBs to ask various questions from one device. Most SNMP managers already have all the common MIBs installed, the vendor-neutral ones, or even the vendor-specific MIBs for really popular products. So here's an example. I've got a manager that has all these different MIBs loaded. And it goes and talks to device number 1 and asks questions out of MIB 1. And it goes to device number 2, asks questions out of MIB 2, same for 3. And quite honestly, maybe the next device, it might use 2 of these MIBs. Just a few questions from this and a few questions from that. And typically 1 MIB per device type. MIBs have a hierarchy. So these object IDs, regardless of manufacturer, they're part of a global hierarchy. And you can see here, so like I have .iso, .org, .dod, .internet, all the way down to system. And now we're describing things like the description, or the uptime, or a name, or something like that. So every OID is unique, and the SNMP manager must know what MIBs the agent is going to use. Or at the very least, it needs to know, okay, I'll start with .1, .0, .2, .3, .4, and then I'll go like .4, .5, .6, .7. So you can have a manager just say, from this starting point number, just continue to go down the line and do like a bulk query. So if the SNMP manager queries an agent with a MIB, or an OID rather, that the agent doesn't know, well, it'll just be like, well, I don't know. Okay, next one. The manager could just start from one point and just say, get this value, get the next one, the next one, the next one, even without me knowing whether you support it or not, because you'll just blow me off for the ones you don't support. You give me information for the ones you do, and you won't for the ones you don't support, and I'll just have that info. So the manager doesn't need to know the OIDs for every single counter on a device. It just needs to know a starting number, and it'll just get next, get next, get next. So how do we use SNMP to enumerate? We can get so much information. SNMP is a great target for enumeration. Often people don't change the defaults. They use public for the community string. They use the same encryption levels. Most versions still use the same clear text version, the older version of SNMP. You might even be able to sniff the community strings off of the wire. Many SNMP management tools include a feature to discover all the MIBs installed on the agents. You could walk the MIB. Just start at a common point and just get next all the way down until you run out of questions to ask. There's all kinds of info we can enumerate from SNMP. We can get devices, hosts, users, groups, services. What software do you have installed? What shares do you have? What are your configs? IP and MAC addresses, ARP table, routing table, VLANs, port and interface status, network traffic, and oh, so much more. Security violations, DHCP leases. I mean, the list goes on and on and on. There are a ton of tools you can use. You can use a very comprehensive tool called the SolarWinds Engineer Toolset, which you can sometimes get for free. Nmap has 12 scripts. Metasploit has a bunch of SNMP modules. There are 2 command line tools, SNMP Walk and SNMP Get. All these others I've used, Observium. In fact, I've used most of this stuff right here. And there are a whole bunch, I've used Spiceworks. There are a whole bunch of tools. Some are free. If you wanted to just query this or that, you could use one of the command line tools, SNMP Get, SNMP Walk. They have the same syntax, and both Windows and Linux use these commands. So SNMP Get, I want to query a single object ID. Just write a script to run regularly to query that thing. Or SNMP Walk, start at a particular OID and just go dead the whole thing. So either SNMP Get or SNMP Walk, the syntax is the same. Whatever options, community string, public, and then the host name or IP address and the OID that you want. So in this case here, I'm going to SNMP Get verbose and version 2C. And I'm querying myself, so this was just a test. The community string is public, and then this long thing is, please give me the name of your operating system. Oh, it's CentOS 7. This is my response back. So this is how we would use SNMP Get, SNMP Walk. Here's an example of using Metasploit to enumerate logins, the SNMP community strings. So, okay, as we go down the line, oh, this one here is using public, yay. This one's using public, this one's using private, this one's using private. Oh, and this one's using internal, private, public. So it'll try to enumerate the names, and now that we know that, we'll just say, yeah, I too use the community string internal, or whatever you want to call it, and I got a whole bunch of questions to ask you. So that's how we can use SNMP to enumerate information. Some Microsoft people, they hear about it, they don't really use it a lot, but oh boy, is it good. That is our look at SNMP. And now, on to the next topic. All right, we have a comprehensive tool called SoftPerfect Network Scanner that was installed, and we're in Server 2016, and I'm going to launch that tool. We're not purchasing a license, we'll just click Continue. This tool can do a lot of stuff. I mean, we're going to scan a subnet, but we're not just port scanning. I mean, we're past that. Let's go in 192.168.75.1 to 192.168.75.254, 192.168.75.254. Now, before we start scanning, let's see some of the things we can do. So let's go to the actions, and we could just do DHCP server discovery right now. We could open up particular device. Let's just discover DHCP servers right now. Let's just click that and give that just a moment. And it will discover the VMware DHCP server at the very least. So it's basically doing DHCP discovers on the various interfaces. And we found a DHCP server right there. Okay, we know right now that we have one. That'd be a really good tool to find out if there are any rogue DHCP servers on a subnet. Okay, let's close that. Let's look at other things. Let's go to options. and we could open up and query WMI, Windows Management Instrumentation. Like I said, this is a service in Microsoft that you can use to query, and they have sort of their own kind of syntax, really similar to SQL, where you can query hardware and software. So let's just click that, and let's mark all of these. Let's try to query the hardware and software, like the CPU, the RAM, the computer model, part, serial, asset tag, product key, if these things exist, the name of the machine, uptime. This is all via WMI as opposed to NetBIOS or some other kind of query. Usually you need some kind of username and password to query this stuff. Very often you only need a regular user. You don't need an administrator user to query things, but if we know some admin accounts, we'll put them in. So what we're going to do is we're going to use a specific account, and we're going to try all login password pairs. We don't have any, so we'll click Manage, and we're going to create some usernames and passwords. We'll click Add. Now, you might not know anything, but the idea of enumeration is to go beyond just simple scanning. So the username, in this case, we know that many machines have administrator. In our case, we know the password is capital PA22W0RD. And click OK. We could add more administrator accounts if we knew they existed. Let's add another one. We know that with Metasploitable, the username is msfadmin, and the password is msfadmin. And if you're afraid you didn't type it right, click the little I here. And yep, I typed it OK. And you can hide it again. Click OK. So we've added some credentials, and let's close that. We have those credentials handy. We're going to try querying all this by WMI. So let's close that. And by the way, you can add more if you want. If you know what the different WMI classes are, like boot devices and stuff, you can add that stuff if you want to, and add WQL as opposed to SQL statements. But that's beyond the scope of what we're doing. So I'm going to close this. We're doing WMI queries. Let me go to Options. You can query remote registry if you want. If you want to query like stuff out of the registry, this is just a few things. Like, I'd like to know the service pack level. That would sure be interesting. And the Windows version and the Windows type, that might be really interesting. So let me close those. What else can I query? Options, services. Sometimes it's nice to know the various services, and you can add more if you wish. I don't care about services at the moment. Let me go to Options. Remote files. Yeah, are there any Outlook or Outlook Express? And you can add more. You could tell it to look for files. Look for specific files. Like if, let's go New. And I wonder if this will work. Property. File exists. If the file exists, the item name, I don't know if star.doc will work or not. How about star.txt? Probably asking for it by doing that. Star.doc. Don't know if those exist or not, or have a full file name. Click OK. No, it didn't like that. So it actually wants us to put in where this thing can be found. So I'm just going to cancel that. That'll take too long. So let me close this. Let me go, and what else? Oh, let's definitely use SNMP here. If you know the MIB numbers in SNMP, and you can do Google searches for it, we can just do some simple querying here. Let me just mark all by SNMP, and let me close that. What we're going to have to do is make sure that we're using the proper community string. What else do we have here in Options? We could look for groups. Yeah, I'd like to see if we have members of administrators. Okay, and we could even add a new one. Let's add domain admins. Domain admins. Are there any members of this would be a global group. Members of a global group, because domain admins is a global group. So it would be domain admins. See if that works. Click OK. And let's close that. Let's go to Options. What else can we? If you had devices that respond to XML, you could use HTTP to talk to them. We know we have one device that will respond to SSH. So I'm clicking SSH, I'm clicking Mark All. And that was that when we look at the logins, the passwords, manage, that is the MSFadmin. So let me close that. What else can we query by? We could look at performance counters. How about PowerShell? I want to use some PowerShell. We could let's use the accounts, try all the password login pairs, and let's try all of the PowerShell queries, SQL Server version. Not that well, maybe we do have SQL running. So we can just do some PowerShell. We could add more PowerShell queries if we want. That is for you to explore later. And let's see, what else do we have? IP address, auto detect local IP range, detect external IPs. No, we'll specify. All right, so we've got our IP range here. We've got all sorts of different kinds of queries that we're going to do here. When we go into the SNMP, let's go back to SNMP here, and just make sure that the community string is set to public. So when I pick something, if it's not public, I can select it and click edit. Now, public is only because that is the default community string. You might have situations where they're using other community strings. A community string is simply an identifier. If an SNMP manager is not using the same community string, then the device, the SNMP agent on the device, can refuse the query. So I've had SNMP community strings that were like Observium or the name of the domain or the name of something else. In our case, I think we just have public. So we'll click OK and close that. So I think we're pretty much ready to let this scan run. Might take a while, so I'm going to click Start Scanning and let it go. And we're finding stuff right away. We'll come back in a moment. Let me just expand this. We'll come back in a moment when all of this is done. Looks like the scan is done. So let's see what we have here. So in 75.1, we were unable to connect or log in, okay, because we did not provide the username or password that this particular host wants. Same thing with 75.2. Windows 8, same thing, because we didn't provide the Windows 8 username and password. But 75.12, we were able to find some shares, and we were able to log in. And we were able to find out the CPU make and model, the amount of RAM it has, the type of computer, part number, serial number, which there was none, but that's okay. And we were able to find out different bits of information as we scroll way over. Our queries turned this information up. We would have to expand each of these to see more. So like see the domain admins there and see the administrators right here. Just expand that. We see all the members. The administrators. Administrators has, of course, other admin type groups that are members. And we can scroll over and see more and more information here. If there's any SQL information, any file listings, any last log messages, any product keys, of course, in our case, not really. And so we can see more and more information here. So we were able to use a number of different protocols, really. LDAP, WMI, SNMP, NetBIOS, to get a bunch of different information about these various devices. So this is using SoftPerfect Network Scanner to use a variety of techniques to enumerate information off of our subnet. Now let's talk about using LDAP to enumerate, the Lightweight Directory Access Protocol. This is the search and edit protocol for an X500 style directory service. Huh? What that means is, if you have Microsoft Active Directory, I can use LDAP to query it. And here's the coolest part. An average user has the right to read almost anything out of an Active Directory database. And there are a few little exceptions. Take an Active Directory class, a Microsoft class, to learn more. But LDAP is really great for us as attackers, as hackers, to enumerate information out of a domain. It listens on and actually communicates on TCP 389. It's clear text. There is a secure version, and that is on TCP 636, but it's clear text by default. And we can use it to obtain a list of every object in Active Directory, including users, groups, computers, user department and contact info, group membership, network resource information. We cannot use it to query things like password hashes, but just the objects themselves, yeah, we can get that stuff. Now, besides Microsoft Active Directory, you can also use it against other X500 style directory services, Novell eDirectory, Open Software Foundation DCE directory, and you might be saying, what the heck is X500? The International Telecommunications Union, ITU, they use these X dot numbers to indicate different kinds of services. So X.500, it uses a naming convention that is hierarchical, very much like DNS, that ensures that every person, every computer, everything in the world is unique, has a unique name. Here's an example of an X500 naming hierarchy. So you've got top-level domains, net, com, org. And then let's say from com, you have a domain called example. Now the DC doesn't mean domain controller, it means domain component, or a level in a DNS style name. So here's one level, com. Below that is example. And com can have Microsoft, CompTIA, EC Council. Org can have all these things as well. Oh, actually, EC Council would be under org, and so is CompTIA. But Microsoft is under com. So at the organization level, you'll have the domain component, the domain name, and then it might break out into organizational units, which are kind of like folders in a database. So you have an OU for people, an OU for servers, and more. You can have OUs inside of OUs. And then finally, you'll have what we call a leaf object, a person, a computer, a service. So this is the hierarchy here. And the X500 style guarantees that on the public internet, when you get down to JSmith of people of example.com, there's only one JSmith with that full name. There might be JSmith of something else, but this one is unique. There are a ton of LDAP enumeration tools. You could use good old Active Directory users and computers. You could use a variety of LDAP tools like LDP. Microsoft even has us use LDP in their classes. Metasploit has a module for dumping hashes from LDAP. That's pretty cool. You'd probably have to have privileges to do that. There are a number of Nmap scripts for enumerating from LDAP. There's JExplorer, Responder, which you can get on GitHub. I mean, there's a ton of things. I'm just listing a few. And when we enumerate LDAP, we would just say, okay, open TCP 389. All right, good. And we want to do a search from this dot that. And now, give me everything you got. Oh, I got administrator, I got guest, I got this, I got this, I got this, da, 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 da. And here is the full path, the full X500 name, what we call the distinguished name of that person, that thing, that service. So LDAP is a terrific tool for querying things like Active Directory online. And if we can sneak in and do some impersonation and stuff like that, we can be dumping whole databases. That's our look at LDAP. And now, on to the next topic. Of course we can use DNS to enumerate. Let's see how. First of all, DNS has lots of record types. This is how we discover computers, and we get a hint of what they do. We could query a DNS server for its records, either the IPv4 address records or the IPv6 quad address records, quad A's. Name server, that's the DNS servers themselves. Those would be our targets for querying. Or MX records, these are the email servers for that particular domain. Or the CNAMEs, the canonical names. These are aliases for these, because, quite honestly, a DNS name is just a convenience for humans. You can have all kinds of names that map to the same IP. Or a pointer record, a PTR, where I come to you with an IP and you give me back a name. We use it a lot for security. Or a start of authority record. If you want to grab individual records, you just query. But if you want to grab the whole database, you do what's called a zone transfer. You could exploit DNS all transfer, AXFR. You could exploit that vulnerability and just grab the entire zone from a DNS server. That means you don't need to know what to query for. You just say, I want an AXFR, give it all to me, baby. Now, DNS server should be configured to not replicate to things it doesn't know. But you have lots of administrators who really were not paying attention or didn't know what they were doing. Or something sneaked by somehow. So some DNS servers are happy to transfer their entire zone away to anybody who asks with no authentication. This will save you, the attacker, lots of time. Or you can just manually request all the various record types and hope that you get everything. There are a ton of DNS enumeration tools. If you want to just use the command line tools, there's dig and fierce, which are both Linux tools, or there's NSLookup, the Microsoft tool, or host. And there are also some Python and Perl scripts and Metasploit modules and Nmap scripts and other kinds of tools. You can also go online to various sites like NSList and IPList to cross-reference domains, host names, and IP addresses. So you can just see some of this stuff here and how they relate. Here's an example of using a command line tool from Kali, DNS Recon. And so what I'm doing is it's Python script. I'm saying DNS Recon and the domain is cisco.com. And it will try to dump everything it can for me. So here's the start of authority and the 2 DNS servers and the, 4 email servers and an A record, a quad A record, a text record, which is, sender policy framework. That's for anti-spam. And trying to get SRV records. What? SRV records? Those are for Active Directory. You shouldn't be able to get those out in the public network. Okay, whatever. Of course, there's the Microsoft tool, NSLookup. We can use it at the command line. You just say NSLookup, some option, name or not, and then the server we're targeting, meaning the DNS server that we're targeting. You can also install this tool on Linux. You would have to install 2 things, one after another. Sudo apt install dnstac-utils, and then after that, sudo dnf install bindtac-utils. The only thing about NSLookup is it depends on the existence of a reverse lookup zone, a PTR zone, for that zone to work properly. And not all administrators will set that up. But nonetheless, here are some examples. NSLookup example.com, just give me all of it, baby. Or NSLookup tac type equals only the name servers. I just want to know the DNS servers for example.com. Or I just want to know the start of authority, which describes things like when the records will expire and how long you have to keep it for before you let it expire and who created it and that sort of thing. We could also say, just give me the email servers or give me anything. Or we could just say, I want to know whatever I can get out of example.com, but I'm only going to query this one DNS server to get it, instead of just taking my chances. Or I could just query via IP address. Or I could say, NSLookup the type is PTR, and then you would have to give the formal reverse lookup name, which is the IP address, backwards, .intecadra.arpa. So these are examples of using NSLookup. You can see here that I've got some examples on the command prompt. NSLookup type MX for ecouncil.org, and it comes back and it says, oh, so the server is this name, that's its mail exchanger, and it has an IPv6 address. Okay, all right. But you know what? I want to know the IPv4 address of this. Oh, okay, well, the IPv4 address is this one right here. And there are 2 of them. Okay. If you'd rather use the Linux tool, dig, Linux Unix tool, you can use that, and it's installed by default. And you can install a very slightly older version on Windows as well. So you would say dig by name, dig by domain name, dig a specific DNS server that you're querying, some host name, some IP address. So these are ways of using dig examples. dig, give me the address record for www.example.com. In other words, give me the IP. Or dig, and I'm giving the IP, and that assumes I want the name back. Or dig, give me the short version of all of the email servers for example.com, or all of the text files, which are usually used for anti-spam for example.com, or the DNS servers, or hey, give me any and all records. You can also use fierce in Linux. So you can try to transfer a zone by guessing a domain that the server is authoritative for. So here's the thing. If I go to DNS server and I say, hey, give me everything you have on that domain, if that server is not what we call authoritative, meaning it doesn't actually have the actual zone file, the database in it, if all it's doing is doing lookups and then caching the results, the zone transfer will only be useful if it hosts the zone, if it's authoritative. So I'm going, there's a DNS server there, and it's run by an ISP, so you can bet that it is authoritative for a whole bunch of customers. It's going to have zones for a whole bunch of domains. But we got to figure out what domains this server actually has a copy of. Now, whether it's the writable copy because it's the primary, the master, or if it's a read-only copy because it's the slave, the secondary, doesn't matter. Just give me a copy. I don't care if it's writable or not. So we would have to try to guess the domain the server is authoritative for. So we could say, dig, give me zone transfer everything, all transfer at, meaning to some specific DNS server, the domain. And if it's not authoritative, it'll tell us. It'll tell us to get lost. We could try to perform a zone transfer against every authoritative name server, and if it doesn't work, just launch a dictionary attack. So we could say fierce, tac, the domain is example.com or whatever the domain is. All DNS servers and some DNS or some IP address. Here's an example of dig. I'm going to query Google's 8.8.8.8 for this particular university. Give me any record you can. And it says, I found it, and here's everything I've got. Okay, great, thank you. Take a look at this. Look at this example here. Look closely. What do you see? Look really closely. I'll give you a hint. Look at the very first line. What do you think's going on here? Look. AXFR domain, looks like domain, but anyway, something.com to some particular DNS server. You see what's happening? And then we get this start of authority, address records, name servers, whole bunch of stuff. What do you think's happening? If you said this is a hacker requesting manually a replication, a zone transfer, you are right. The hacker is using dig, and you can tell it's dig version 9.7. And they are asking for this domain against this DNS right here, give me all the records you can. And it looks like it succeeded, too, because it got all this stuff back. So that is how we can use DNS to enumerate when we are digging into our hacking. And now, for something completely different, now on to our next topic. Let's talk about how we can use SMTP to enumerate information. We need to back up just a little bit and talk about how email works. I mean, this is not an email class, but you need to have a sense of how these things work to become really effective as an attacker, as a hacker, as an ethical hacker. We can see that there's a client over here who wants to send a message to their friend. And we have two different domains. We have acme.com and we have example.com. And the internet is between them. And there's some DNS server on the internet. Okay, the client is configured to talk to its own email server. This client belongs to acme.com. This client over here is configured to talk to its email server, for example.com. So the client sends an email. The user composes one, they send it off. If they're using webmail, they'll use HTTPS. But if we're using a normal email client, we'll use SMTP. The email is sent to the email server. Now, the email server has to figure out what to do with this message. So it goes and queries whatever DNS server it is configured to use and says, hey, I have a letter that I need to deliver to the mail server for example.com. Can you tell me who it is? And the DNS server says, yes. This mail server, whatever its name is, that handles example.com. And what's so interesting is an email server can actually be an email server for several different domains. And that's how the bigger cloud-based email servers work. You've got one server, effectively, one server handling a whole bunch of customers and all their domains. So it can be like a GoDaddy handling all these different little customers and domains. Okay. So the DNS server says, yes, this is the MX record for example.com. Oh, and by the way, this is the A record, the IP address. Great. So this email server going across the internet will send via SMTP again the message over to this example.com email server. Terrific. Now, that email server, assuming it's a mailbox server, is going to just hold that message for that user. And it's up to the user or their client app, Outlook or whatever you're using, Outlook, Thunderbird, whatever. It's up to the client app and the user to decide, okay, I'm going to go fetch the mail now. Otherwise, it sits in the mailbox. But you don't use SMTP to fetch your mail. You use SMTP to send mail to somebody. And your server uses SMTP to send to another server. But when I'm on the receiving end, I don't use SMTP to go and get my email. I will use POP, POP3, IMAP, IMAP4, HTTP, HTTPS, or even in a Microsoft LAN, RPC. I'll use one of those protocols, not SMTP. So SMTP is for sending, and then some of those other protocols are for receiving. So that is how basic email works. The Acme client uses SMTP to send email to the email server, its own email server at acme.com. That email server does a DNS lookup to get the MX record and the IP address for the destination. Then it uses SMTP to send the message to the email server on the other end, which then puts it into the user's mailbox until the client decides to go and pick it up. So how can we use SMTP for enumeration? Well, SMTP as a protocol has 3 built-in commands that are useful. It has more than just 3, but 3 that are useful for enumeration. There's verify, right here. Verify will validate that an email address actually exists. There's expand, to expand a mailing list into the individual recipients. And then there's recipient 2. That specifies the actual recipient. Now, why do you care about SMTP enumeration? Because you want to send phishing emails. That's why. And you don't want to just send it to dead addresses that don't exist. We will use these SMTP commands to manually query an email server. Hey, does this exist? Or I've got a distribution list. Can you give me the individual addresses? And now it's time for me to send a fish or a spearfish or a whaling message to my target. There are any number of SMTP enumeration tools. You can use Telnet if you want, although that's pretty hardcore. You can use Netcat and a whole bunch of others. There's SMTP user enum. There's Kali ISMTP. Metasploit has modules. Nmap has scripts. You've got a variety of choices. Now, this is a fun one. Granted, you wouldn't want to work like this all the time, but we could use Telnet to manually send a message without even having an email client. So let's check it out. We would say telnet, and then either the name, which is it has to be a resolvable name, or the IP address, and then 25. Because the telnet client, of course, is going to use 23 telnet by default. So you have to say telnet and the target email server 25. That's the SMTP port. You will get a message back. And then you'll say verify test@example.com. Please verify for me that this email address actually works. If you get a message code in the 200s, then the server has accepted the request and the user is valid. You get a message code in the 500s, like 550, that user account does not exist or doesn't exist anymore. So, if you want to send an email the fully manual way, hardcore, using telnet, let's do it. First of all, you'd say telnet some target 25. And then you would say hello, that's the new version of hello example.com. And then you would say mail from, in the meantime, you're getting responses back, okay? But this is what you send. You say mail from, you make up some name. This doesn't even have to exist. Who it's coming from, we all know from all the spam and the phishing we get that the senders can be anything you want. They don't even have to exist, I just say mail from some fake name at some fake domain. And then I say recipient 2. I want to send an email to this person at hotmail.com and that person at yahoo.com or whatever, whoever they are. Now the recipient 2s, these are the ones you really want to talk to. You really want to target them. They should be real. And once it says okay, then you say, okay, here comes the data. Issue the command data. You do all of these one at a time, right? Now, subject, blah, 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 some subject. Hello, and then one line at a time, this is the body. Blah, 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 sending a test email, blah, blah, you too could win an iPad by clicking this, blah, blah, something, your friend, whatever. When you are done, and you're ready to just say, okay, I'm all done, you press enter, and then a dot, and then another enter. So you put all these one by one, then you go enter, dot, enter to finish. And it'll say, okay, goodbye, and you just say quit, Q for quit. Now, if you're really going to do this using telnet, pre-create this in a text file and then just paste them in one at a time. Don't try to type them, because if you make a mistake, you've messed up. You'll have to totally restart. There's no back button in this case. This is a hardcore way of doing it. Probably you want to use an actual tool and not just manually hand type these things. So you could go into Kali Linux Metasploit, just create a list of possible email addresses and save it by some name. Then you open up Metasploit and you enter these commands in Metasploit. You're going to use auxiliary, which is usually for things like scanners. Use scanner SMTP enum. And then you say set remote host, set our hosts, and then the IP address of the email server you're trying to target. Then you say set the remote port to 25, because they're listening on 25. Then set the user file to the path to that little list of possible email addresses. Then you either type run or exploit, and it'll come back and tell you, after querying the server, do they really exist? Now, if you want to verify one email address, you could just say, I want to find out if moo@example.com is a valid email address, because if it is, I'm going to try to fish them. So SMTP tac user tac enum, and then M verify. That's the command I want to use, the verify command. Tac D for the domain, example.com, tac U, the user, moo, and tac T, the email server IP. So please find out for me if moo@example.com is truly an email address that I can use. You can also use SMTP user enum and supply a list of usernames to verify if they exist. So if you look here, we're running the command verify you, and then I just have a whole list right here against this email server. And it'll go down the line and it'll run several of these at the same time. And then it'll say, okay, this one exists, that one exists, that one exists, and that one does not, that one does not. Now you know all these legitimate email addresses. So that's getting our stuff ready for a phishing campaign. Here's another tool, Kali's ISMTP. Verify that email addresses in this list actually exist. So we say ISMTP tag H, the host, whatever the email server IP is, :25, that's the port they listen on, and please use this text file, and I'm giving the full path to it. And then it goes down the line and tells me valid or invalid. So this is how we use SMTP for enumeration. And the output from this is something we're going to use in a phishing or spear phishing or whaling campaign. Or possibly we use those because we figure they log on with their email address. We use them as usernames as well. So that's SMTP enumeration. Now, on to the next topic. We want to see if there are any email addresses we can take advantage of. See if we can query an email server for actual email addresses. Now, we're going to do this activity white box style. So I have the email server open, mail enable. And when we click the mailboxes here, you can see there are a number of mailboxes right here. And also there's a group called managers. We would call this a distribution list. It actually has 2 members in the distribution list. And also on this email server, the IP address is 192.168.98.153, but I want to call to your attention something right here. If I type net space user, you can see that the users on this machine are the administrator, moo, guest, student, and then some service accounts. So you can see that the operating system accounts are not the same as the mailboxes. So the mailboxes are just for this application. They are not necessarily operating system accounts. Although when you use something like Microsoft Exchange, they will be operating system accounts. In fact, they will be Active Directory accounts. But just keep in mind the fact that what's on the email server might not necessarily correspond with what's in the operating system. And I'm going to come back to that in just a moment. So how do we enumerate off of an email server? Well, the old-fashioned way was to use Telnet. We're over on Kali. I'm switching over to Kali. I'm logging into Kali right now. And I have a terminal window open for Kali. And the old Telnet was to just say Telnet and then some target, like 192.168.98.153, which was the email server. Let me just get rid of this thing here. We'll double check that. Yes, it is 153. Okay. And since Telnet uses port 23 by default, you have to specify the TCP port 25. You hit enter. And you can see right away that the email server has given us a banner. And it's basically saying hello to us. Now, in the old way, you could just simply ask it to verify an account. And you could use the verify command to do that. SMTP has a few what we call methods. Verify, VRFY, is one of them. So we could ask it, please verify moo at example.com. And we press enter. This 250 means yes, moo does exist. Now if we ask for something that does not exist, let's verify, say, Maina at example.com. Nope, there's no Maina here. Okay. That's one way. That's one method, the verify method. But a lot of email servers now are being configured to not respond to verify simply because it was abused so much for spamming. So another thing we could try is we could try the expand command, EXPN. But this means and a known distribution list. And we know from over here that we have a distribution list, although in this product they call it groups, called managers. So we can try to expand managers. expand managers at example.com. Press enter. And yep, there are 2 members in that distribution list. But the expand command also, like the verify command, has been kind of configured away because it's been abused so much. So the one thing you can do with an email server is use the recipient command, the recipient method, because that's just normal receiving email for somebody who has a mailbox. Now, you can actually do the whole handshake with an email server and manually give it an email. We'll just do it just for the fun of it, although I don't recommend it for practical purposes. We already have a session with this thing, so we're just going to say hello and then some arbitrary thing, and it's saying okay, hello, gotcha. Then we're going to say mail from, and we can make up anything we like, hacker at forget.u. And unless this thing is checking for spam, it's going to say, okay, hello. And then here's the key. We say recipient 2, that's RCPT2 colon. Now you got to be careful because if you screw up, you have to restart the whole thing. So recipient 2 moo at example.com. And it says, okay, 250, there is a moo here, go ahead. Now we just say data. Now, if you just wanted to prove that moo existed, you could stop right here, but let's just actually send an email. So we'll say data, and it's saying, okay, and when you're done, just type a period. So we're going to do that. We'll say subject test, enter. And then we'll just say, hey, moo. And then with that, we'll just hit a period like they tell us to. And it says we're done. And then all you have to do is say quit. And we have actually manually, through a telnet handshake, manually sent an email to moo. So we can use the verify, the expand, or the recipient methods in SMTP to try to see if there are valid email addresses there. Now, using telnet to validate email addresses is all very fun, but it's not really practical. There's a tool you can use in Kali called smtp-user-enum. And we're going to type that in and press enter. And we're going to take a look at its syntax. It's actually quite easy to use. You just say smtp-user-enum, some options, and there are a few that we will care about, and then either small u for a single username or capital U for a text file of names, and then either small t for an individual email server or capital T for a text file that's a list of email servers. And the options that we're most interested in are, besides the U's and the T's, are this tac cap D for domain. So let's say you have a list of usernames that's just names, Sue, Sally, Joe, etc. You would want to also say tac cap D and then example.com or comptia.org so that we would append the domain name to the usernames. So let's see some examples. You can see that it has the methods. You can specify tac cap m and then just say verify or expand or recipient. So in this example here, we would use the verify method, and the cap u means we have a text file of users, but we're going against a single email server here. So out here in the file system, I have already set some text files. You can see that there is mailboxes, which we'll open up. And you just open it with a text editor. And you can see that these are all full email addresses, moo@example.com, sally@example.com, etc. So that's mailboxes. We also have users. Open that up. And it's just moo, sally, etc. without the @example.com. So depending upon our switches, we'll either use the user's text file or the mailbox's text file. So let me just minimize this. So let's say that we wanted to try the verify against users.txt. And if we did users.txt in our case, because we don't have the @example.com, we would have to also say tac cap D example.com to include that. So let's say smtp-user-enum, tac-cap-m, verify method, and tac-u, users.txt, but we have to give it a path. So in this case, it is in the profile of the root user. So if we start in other locations, just so you can see the breadcrumb, open up computer, we can see the root user right here, and in the root user is this. So we would say /root / and then it would be users. It doesn't have the .txt extension, not ours. And then we would say tac-cap-d for the domain, and it's example.com. And then tac-cap or small t for a specific target server, 192.168.98.153. And if we've done this correctly, it's going to run and it's going to test. It's going to try everyone in this list, appending this against this, using the verify method to see if they exist. Hopefully we didn't forget anything. Press enter. And we can see that it concatenated the names with example.com, and we can see that these people do indeed exist. Now this just tells us that they exist on the email server. Metasploit also has a tool. We can go to Metasploit and we can see it. But the Metasploit tool actually is not as good in that regard as, say, the SMTP user enum. It actually will see if there are user accounts in the operating system on the email server, and then the hope is that those user accounts also have email mailboxes, which we saw is not always the case. Okay, so I have Metasploit here, and if I just do a search for smtp_enum, let's see if there are any modules here. And yes, there is an auxiliary scanner, smtp_enum. However, don't let this kind of throw you off. It's looking for user accounts that it can use to log into SMTP or actually just verify that they exist. It will not return a whole list of user name or mailbox names. So let's just try it though. Use auxiliary /scanner /smtp/smtp_enum, and then let's show options to see what else we have to type. We do need to put in the target, the remote host, and we do need to specify the user file. We also have to say whether or not this is Unix only, and in our case it's actually a third party, so we're going to say Unix only false, because it's not just like a Unix or a Linux based email server. So let's set our hosts, and even though it shows plural, there's only one. That's just the syntax for Metasploit. 192.168.98.153. That's that email server. Let us set Unix only to be false, and then let us specify that the user_file, and here's where you do not pick one with email addresses unless that's how the users log on. So user_file /root, and then it was mail or users, and that was that file that we had. Press enter. Now let's, oh whoops, I forgot to say set. Set user_file /root, that's the user, and then users is the name of the text file, and then let's show options. Make sure we didn't forget anything. Looks pretty good. If we didn't make a mistake, we can type run, and it shows that nobody was returned here. It went and it talked to this thing, but didn't return anybody, because remember how I said that the user accounts in the operating system were not necessarily the same as the mailboxes. I did expect it to show up moo, but since I guess there is no coordination between this third-party email server and the Windows operating system, it turned up nothing. So in that case, Metasploit was not useful to us. However, the SMTP-user-enum was highly useful. So we now know how to use Telnet and a couple of Kali tools to try to enumerate whether or not users actually exist on an email server. Let's do a quick wrap-up of enumeration. What are the countermeasures to enumeration? Well, try to use protocols that are encrypted rather than clear text. Disable NetBIOS and SMBv1. Change the SNMP community string or strings. Disallow DNS zone transfers to unknown servers, so I can't do an AXFR zone transfer. Maintain separate DNS servers for the internal network and the public network. We call it split DNS. Consider disabling some of those SMTP commands on your email server, especially verify and expand. Use file system and share permissions to access to sensitive content over the network. Perform your own tests, see what you turn up, and then shore it up when possible. If you find some vulnerabilities that you can enumerate from that you cannot fix, then implement some other compensating control. Like, okay, I can enumerate information out of this medical instrument because it runs Windows 7 and the vendor is just not going to update it. All right, then, if that's the case, don't put it on the network. That would be our compensating control. Keep it off the network. That's just one example. Let's review the key points. Enumeration is a systematic process of querying devices and systems and servers for information, more than just port scanning. We want information from that system. The key is that it looks like a normal client request. It does not look out of the ordinary. Even if you're using special tools, from the target's perspective, it looks like just legitimate client requests for information. Nothing to arouse any alarms. But you can get all kinds of info. Operating systems, services, groups, users, network info, machine names, configurations, installed apps, service banners. And there are many protocols, and we've checked some of them in much greater detail, that we can use to enumerate information. So we can use the file transfer protocols, SNMP, the remote access protocols, SMTP, DNS. We can use the web protocols, HTTP and LDAP and SQL and NTP and other things as well. So that is our look at enumeration. Now let's move on. Let's do some website enumeration. You'll need Kali Linux and Metasploitable for this. Okay, so when we're going after web servers, we need to first of all know what the IP address is, of course. We also need to know, are they on a standard port like 80 or 443, or are they on a non-standard port? And then what directories do they have? Because just because you can go to a website doesn't mean you know all the directories that are available. And just because the directories exist, it doesn't mean that the web developer actually put links in the main page to those directories. Sometimes you have specialized apps or something where you can't just browse to find those directories. So in that case, we have to guess. So the first thing we want to do is just find out what port the web server or services are listening on. So we saw we can do an nmap tac s cap v and then some target. I'm going after Metasploitable right here, 192.168.98.155. Yours will be different probably. Press enter and just let it run. It's going after the 1,000 most popular ports, and it's interrogating every port to see the version of the service that's listening on it. And so I can see here in the results that yes, it has a normal HTTP server, Apache, HTTPD version 2.2.8. There are also other web servicey type things. There's Apache 8009 TCP for Apache JServe and 8180 for Apache Tomcat. So when we've determined the ports, and by the way, that just nmap without specifying the ports, we'll just go for the most common 1,000 ports. You could just go for every single TCP port there is. You could just say nmap tac p tac, which means all 65,536 ports. Actually, we don't do zeros, so it's 65535, and then tac s cap v, and then after the target. This one will take a while, so I'm going to kill it in just a moment, but I just want to show you. And we could let it go, and it'll take some time, and it will show us if there are any other ports, and it will interrogate them. Now, I'm just going to kill this one, so for our demo, we don't need to look for that. Now, the next thing is, what are all the directories on the web server? We don't know. I mean, there's no guarantee that there are links to it or anything. We're going to have to guess. So we're going to use a tool called dirbuster that will help us. It's built into Kali. So we just type dirbuster and press enter, and it's going to pop up this GUI tool. So what you got to do in dirbuster is you have to put in the target URL and the port. So maybe it was a non-standard port, maybe it was standard. You can put in an IP address or a resolvable name, either one. So let's HTTP, since it's not HTTPS, and Metasploitable is 192.168. Get my cursor out of the way. 98.155:80. And then you have to tell it, here's a list of possible directories that have just been compiled by people. Try those and see if they work, because there's no guarantee that we'll find links. In fact, very often directories don't have links to them. So what we do is we're going to browse. Dirbuster comes with some already. You can download others off the internet. I'm going to click Browse. And where we find it is we have to go up to the root directory. And then we're going to go into User, USR. And we're going to go into Share. And we're going to find Dirbuster, which is right over here. Just scroll over a little bit. And there it is right there. Whoops, did I go too far? Now here it is. Open that and then go to word lists. These are just possible names of directories that it will try. Now, if you take some of the big ones, it could take like a day. So we're going to take a small one right now, and we're going to select that list, and we're ready to start. And it's just basically trying different ones. So you can see that it's trying. Sometimes it's successful, sometimes it's not successful. And here will be, so it's coming up with a warning, unable to determine consistent fail response. It wants us to put in a regular expression. We don't know one. So we're just going to cancel. It's going to warn us that, hey, it may generate false positives. You sure? Just say yes, because regular expressions is beyond the scope of this class. And we're going to let it run. And this one says it can be done actually in 2 hours. We're not going to wait 2 hours, but we're just going to let it run a bit, and we're going to see what it has found already. And you can see it's just trying different things that are in that list. Some things are succeeding, some things are not succeeding. We're not even at 1% here yet. So I'm just going to let it run just maybe one more minute, and then we're just going to see some of the results that we have. So it's finding different things, it's finding directories, it's finding stuff. When you see a 200 like that, then that means it's okay. The only thing that doesn't mean it's okay is 404. That one's not found. Everything else is either like unauthorized, which is all right because it's there. It's okay if we can't get into it at the moment. We know it's there. So let's bring this forward here, and let's just go ahead and stop this and see what we have so far. I mean, we aren't even at 1%. So we'll stop it. We will look at the results. So let's hit the results right here. We'll click this, and we can see that a lot of stuff was already discovered. These are the responses. The 404s are the only thing that matter. Then we can look at the results in a tree view, so which means we could like drill down. So there's index.php. inside of index, inside of CGI bin, nothing, icons, twiki. But we can drill down, and if we had let it run, of course, there would be lots of stuff to drill down into. Drill down, and it's nowhere near done. So here is how we have been able to brute force using a list of possible directory names and just going through and trying it. We've been able to just throw it against this website and discover stuff that they thought they were clever and they thought they were hiding it and no links to it, but we've turned it up through brute forcing. And that is how we can enumerate pages and subdirectories that we otherwise wouldn't see from a website. There are a few more enumeration types that you should not only know for real life, but you're certainly going to need to know them for the exam. Let's take a look at them. Let's start with the Network Time Protocol, NTP. NTP is used to synchronize clocks on a network. It uses UDP 123, and it can maintain time to within 10 milliseconds even over the internet. You would query NTP for a list of hosts that are connected to the NTP server. Client IP addresses, system names, operating systems, internal IP addresses can be acquired if the NTP server is in the DMZ. Now, Active Directory, Microsoft, they have their own little thing. They call it Windows Time. It is not NTP. They use Windows Time, and it's kind of loose, but they use it to synchronize their clocks within a domain. And there's a particular domain controller called the PDC emulator, primary domain controller emulator. It is the authoritative source of the time for a particular domain. But that PDC emulator can then synchronize to other sources via NTP. So what you would typically do is you would have your PDC emulator in a domain synchronized to some clock out in the internet, and then it would in turn synchronize to all of the machines in that domain. Now, you're not going to have routers and switches and firewalls using Windows Time. They'll use true NTP. They should be synchronized to the same source that the PDC emulator is synchronized to. So they'll all be very close in time, very, very close. It's really important that you have synchronized clocks so that if you as an admin have to cross-reference events that are happening, everybody's timestamps need to agree so that you can see, oh, first they did this, then they did this, then they did this. If the timestamps are way off, then you can't really correlate what's going on. NTP has various commands. So you could NTP date to query a time server. So I could say NTP date query this particular time server. This is actually a group of time servers, pool.ntp.org. Or NTP trace. Trace is a chain of NTP servers back to the primary source. You know, NTP is actually a hierarchy. So you'll start with like an atomic clock, and then it'll go to these first tier and second tier and whatever, this hierarchy of servers. By the time you get down to what you're synchronizing to, you're probably down at the fourth level. And that's okay. In NTP, we call them strata. There's the NTPDC. So this monitors the operation of an NTP server. So in this example, we are requesting the last 600 clients that connected to this time server. So we would like to have a monitor list, and then 600 is the default, of the name or IP address of the NTP server, like pool.ntp.org. There are a ton of NTP enumeration tools. Here's just a few of them. Here's an example of one of the GUI tools. Now, you know, most people these days use voice over IP for phones, VoIP. We can enumerate VoIP as well. You know, VoIP uses SIP, the Session Initiation Protocol, to basically set up the call, manage it, and not only voice, but video calls over IP. And it'll hang up and it'll just manage the whole call. In the old days, it was PPP that it did it, but now it's SIP. PPP didn't do video. So SIP is clear text. TCP 5060. Now, you can have SIP TLS encrypted, but there's no guarantee that that's being used. SIP is just to manage the call, to make a phone call, do some handshakes, and hang up. The data is carried by something else called the Real-Time Transport Protocol, UDP 5004, or the Real-Time Transport Control Protocol, UDP 5005. Okay. When we enumerate VoIP, we want information like, what is the address of the VoIP gateway that connects this VoIP system internally to the public switch telephone network? Or give us information about the VoIP PBX. This is the thing that it has its own IP address. It's not like a default gateway, but it will route calls to specific phones within the internal network. Or give us information about client software so we can see if there are any exploits for it. Or tell us who the users are and where their phone extensions are. We can use this to launch various VoIP attacks. We could do denial of service, session hijacking, caller ID spoofing, eavesdropping, spamming over internet telephony, VoIP phishing, and the like. So let's discover target VoIP information first. We could do a Google search, or we could search Shodan for public information. We could use Nmap and a tool called SIP Vicious, yeah, if you remember the punk rocker Sid Vicious, to map out the internal VoIP network and basically go down the line and see who's responding, who's willing to do a handshake. We could use Wireshark to identify the SIP users. We can use job sites that list knowledge of a specific VoIP system as a skills requirement and go, aha, those guys use whatever VoIP system they have, so let's look for just whatever exploits we can find for that kind of system. We could search for the following information: the public IP of the VoIP server, the gateway really, the VoIP network, its infrastructure, devices connected to it, their open ports and running services, user information, extensions, device info, logs, and information about the VoIP server itself, the vendor, the model, operating system, ports, and the like. You can do some Google dorking to find VoIP targets on the internet. So here are some of the dorks. Looking for Linksys or Cisco, or find Cisco Call Manager, which is like we used to call it, well, I guess we now call it Unified Communications, but it's the voice and multimedia management system for Cisco phones. Or there's another product called Asterisk, and that's actually open source. Find the web portal for an Asterisk version. I have installed Asterisk VoIP systems and Asterisk PBX. Or find some VoIP login portals, or search for Linksys phones. Here's an example of using SIP Vicious. So it's an auditing tool to scan for and enumerate SIP devices. It'll send SIP invites or option packets to see if there's a response. It's basically doing sort of a handshake to see, hey, are you a VoIP device? You want to talk? Okay, well, forget it. Change my mind. But it's kind of like, port scanning in a way. It can do denial of service floods. It can enumerate SIP information. It can leak the hashing. It can bleed or inject data. And it can fuzz, in other words, trying to see if we could do a buffer overflow. Here's an example. Let's SV map a whole subnet. And then it's going to go down the line and goes, well, we were able to talk to this address and this address and this address, so those are possible targets. Okay. We know that IPsec is a VPN protocol. Actually, it's two protocols that work together. You can enumerate stuff even off of IPsec. Now, IPsec is the single most popular VPN protocol that is not like a web-based protocol, not an HTTPS-based VPN. IPsec, we can enumerate. IPsec VPNs are digitally signed and optionally encrypted using either data encryption standard, which is long out of date, triple DES, also out of date, or the advanced encryption standard, which is the version we're using now. We could use Nmap or other scanners to identify those IPsec VPN servers because they'll listen on an IKE port. IKE is the handshake protocol for starting an IPsec session because you have to actually say, hey, I want to start a VPN, let's handshake, and let's agree upon a session key. So a little bit of it is in clear text first in the very beginning. You can also use IKEScan and PSK crack to try to capture and crack a pre-shared key hash. If I can crack that, then I can intercept and read whatever you're doing on your VPN. Whew. Okay. So here's an example of using IKEScan. It's a command line tool. We're going to try to discover, fingerprint, and test IPsec VPN servers. We can determine who's running IKE. I like IKE. And we would display the hosts which respond to IKE requests sent by the scan. And we can determine which IKE implementation they're using. So we could record the times of the response and other fingerprinting techniques. And we can identify VPNs from different manufacturers, Cisco, Checkpoint, Microsoft, Nortel, etc. Then we could try to crack some keys. Look at this. Starting PSK crack, running in dictionary cracking mode, and it found the key. Woohoo! Using a SHA-1 hash, which, by the way, I just saw a thing. The SHA-1 now is no longer recommended for hashing. It is recommended that because SHA-1 is only 160-bit, it is now recommended you use SHA 256-bit or 512 or 384-bit at least, or higher. So with PSK crack, it's going to try to crack IKE pre-shared keys, because very often, especially devices or lazy Microsoft administrators, instead of using actual public-private key pairs, they'll just put in a pre-shared key, a password. And we're going to try to crack that using this PSK crack tool. It can work in dictionary or brute force mode. And in this case, it found it. Key number 123456. Good. That means I, too, could create a VPN, an IPsec VPN, because I know the key you're using. So I'll use it. We'll both use it. Yay! Because it's pre-shared. And then I'll make a connection. You can also, a little bit, do some enumeration with IPv6. Now, IPv6, the addresses are so expansive, so big, that you can't do the normal scanning, like Nmap port scanning, but you can use what we call DNS IPv6 grinding. We can identify the IPv6 servers through DNS grinding. Now, grinding is a dictionary attack of possible host names, and it just makes quad A requests. Of course, if you can manage to just query a DNS server for anything, just say, type of quad A, and, it'll give you that. But if you can't, use the DNS grinding dictionary attack. And then there are a variety of grinding tools here, and you can even install this tool suite to get the DNS grinder on Linux. Here would be an IPv6 enumeration example. So I'm going to use DNS Dictionary 6. And what I want to do is I want to see if there are any IPv6 hosts available on example.com. This 6 means how many threads, how many simultaneous processes are going to be working on this. So it thinks it's going to get this done, go through this whole dictionary in, about a minute. So it detected OpenDNS. Okay, great. They have a wildcard domain configured. Oh, well, we found an IPv6 address right off the bat. And here's another one. Oh, and here's a v4 address as well. So I found a domain name, one v4 address, and 2 unique IPv6 addresses that are now potential targets. And finally, we have the Border Gateway Protocol, BGP. BGP is the routing protocol used on the internet. It's used between what we call autonomous systems. An autonomous system is a big network that has a number assigned to it. It's a 16-bit number. The lower numbers are assigned to commercial ISPs, and then the higher numbers can be used internally if you want to use BGP within your gigantic network. So we use BGP. BGP is actually very slow to converge. The routers are slow to update each other. ISP uses BGP to choose internet routes. It is slow. Like, if something happens and a BGP route goes down, it's going to take 2 hours, but it will correct itself. Whole systems, not individual routers, whole systems are treated as a hop. So like in a normal routing protocol, you would go router to router to router to router. Each router is a hop. In BGP on the internet, whole systems, AT&T, Verizon, these are hops. And BGP has a whole mechanism inside of it. Take a Cisco class if you really want to learn about BGP. But there's some stuff you can get from BGP enumeration. So we know that traffic between networks on the internet is controlled by using BGP and autonomous system numbers. Now, individual organizations can also use BGP, and IANA will assign autonomous system numbers to the regional internet registries, which will then allocate those numbers to ISPs and large organizations. Large means you have to have 50,000 nodes in your network, okay? Got to have at least that. Then you can get an autonomous system number, which then allows you to manage how you're going to route to and from the internet. So you can use Whois or the HE BGP toolkit to enumerate an organization's autonomous system number, IP addresses. In BGP, we call IP addresses, whole network addresses, we call them prefixes. If you know the prefix, it gives you a target to scan. So here's an example. We'll do a Whois to reveal the blocks of network addresses and the AS numbers for Nintendo, the gaming company. All right. So Whois TAC A Nintendo whatever. We go, oh, okay, Nintendo of America, and this is their network block in IPv4, all right? And they have another network block, and by the way, their autonomous system number is this, AS11278. We can also use this website, bgp.he.net, Hurricane Electric. Okay. We can just say, hey, let's search for AS11278, Nintendo of America. And we can see all the IPv4 addresses, we can get Whois information, we can get autonomous system information, etc. So doing a little bit of BGP enumeration is one way to get target IP addresses for the internet. Now we've seen these various additional types of enumeration. So now let's move on. Let's do a quick wrap-up of enumeration. What are the countermeasures to enumeration? Well, try to use protocols that are encrypted rather than clear text. Disable NetBIOS and SMBv1. Change the SNMP community string or strings. Disallow DNS zone transfers to unknown servers, so I can't do an AXFR zone transfer. Maintain separate DNS servers for the internal network and the public network. We call it split DNS. Consider disabling some of those SMTP commands on your email server, especially verify and expand. Use file system and share permissions to restrict access to sensitive content over the network. Perform your own tests. See what you turn up, and then shore it up when possible. If you find some vulnerabilities that you can enumerate from that you cannot fix, then implement some other compensating control. Like, okay, I can enumerate information out of this medical instrument because it runs Windows 7 and the vendor is just not going to update it. All right, then, if that's the case, don't put it on the network. That would be our compensating control. Keep it off the network. So that's just one example. Let's review the key points. Enumeration is a systematic process of querying devices and systems and servers for information, more than just port scanning. We want information from that system. The key is that it looks like a normal client request. It does not look out of the ordinary. Even if you're using special tools, from the target's perspective, it looks like just legitimate client requests for information. Nothing to arouse any alarms. But you can get all kinds of info: operating systems, services, groups, users, network info, machine names, configurations, installed apps, service banners. And there are many protocols, and we've checked some of them in much greater detail, that we can use to enumerate information. So we can use the file transfer protocols, SNMP, the remote access protocols, SMTP, DNS. We can use the web protocols, HTTP and LDAP and SQL and NTP and other things as well. So that is our look at enumeration. Now let's move on.